Hello, everyone. So I just wanted to go over and make sure that you guys understand again how to do the derivative rules. So we talked about in class today how to take the derivative of a constant function, a linear function, a power function, and if we had a constant times a function or a function plus a function. So we basically took care of linear, power functions, constants, polynomials. Okay. So using these rules, we're going to actually find the derivative for all of these. So looking at the first one, we know that the derivative function of a constant is just 0. And so since negative 100,003 is a constant, we know the derivative is 0. Okay, College Board loves to fool you guys with throwing out there, like for the function e. We know e is approximately 2.718. So it's a number. Okay, so that means that the derivative of e is just 0. Okay, and then if we have a constant times a function, or I should say a constant times the variable, the derivative of that would just be the constant. So the derivative of this is just 2. Okay. And now I'm just going to apply, here I want to apply the power rule. Okay, so I want to bring down the power, right? So I got to bring down the negative 7, x to the negative 7 minus 1. And then when I simplify that, I get negative 7, x to the negative 8. And we want to recall, if you want to simplify this even further, which we'll get more practice with later, but x to the negative n is 1 over x to the n. So we know that this is going to be negative 7 times 1 over x to the 8th. And so if you put this negative 7 over 1 and multiply across, we get that the derivative is equal to negative 7 over x to the 8th. Okay, and just to recap, I just rewrote x to the negative 8 as 1 over x to the 8 using our exponent rules here. Okay. All right. And so when we go to the next one now, we have a function minus a function plus a function. So I'm going to use not Leibniz notation. Sorry, we're actually going to do that later. But Newton's notation, right? Because Isaac Newton's the one that invented calculus. You'll find out later that there's actually another mathematician that also invented calculus, and his name is Leibniz. Okay, and he has his own notation. But for right now, we're going to use Newton's notation. So Newton's notation says that if I want to find the derivative of the first function, I'm going to use parentheses tick mark. And that just means I need to take the derivative of the first minus take the derivative of the second plus take the derivative of the third. Okay. And so see how I have 3 times x squared? So I have a number times a function. So using this rule here, rule 4, I'm going to copy the constant times the derivative of the function. So I'm going to copy the 3 times the derivative of x squared minus the derivative of 4x is just 4 plus the derivative of a constant, which is 0. Okay, so a constant by itself, the derivative is 0. But if I have a constant times a function, that's where I copy the constant times the derivative of the function. So you're kind of seeing the differences there. And so this should be 3 times 2x minus 4, which is equivalent to 6x minus 4. Okay, and so just so you know, when I brought down that 2, it was to the 2 minus 1, so that exponent didn't go away. So you don't want to forget to subtract 1 from the exponent. I just simplified it to the first power, 2x to the first, but that's just the same as 2x. Okay. So let's go ahead and look at practice 2. So now these examples are getting a little trickier, right? This one has like an exponent of pi, which looks scary. But we want to remember that this is really just a number. So I really just have, x to a power or x to a number. So I can still use power rule here. So I'll just write use power rule. Okay, but what might look weird to you is that x divided by 2. So in this case, we don't have a function divided by a function. We just have a function divided by a number. And so we can rewrite that as multiplication, so that makes it a little bit easier to look at. So visually, what I'm going to do first before taking the derivative is just rewriting this function as x raised to the pi plus 1/2 times x. Okay, and so that's equivalent, right? Because 1/2 times something is the same thing as dividing by 2. But then the reason why I wrote it as 1/2 times x is because now when I go to try to take the derivative, I'm going to know exactly what to do, right? So if I take the derivative of the first plus the derivative of the second, so I'm going to get that this is pi x to the pi minus 1 plus 1/2. Okay, so even though it was pi, you still bring down the pi in front, and then I can't simplify pi minus 1, so I just leave it. Okay. All right, and then in part B, we don't have a rule yet. We will eventually for product and quotients, meaning like if you're multiplying two functions together or dividing two functions together, there's specific rules for that. But we don't have anything other than the rules we're given at the top here. So nothing really deals with division or multiplication. So what we're going to have to do is we're going to have to multiply this out, right? Do distribution. And then it will turn into something we do know how to take the derivative of. So we'll get g of t is equal to t squared plus 2t plus 1t plus 2. So we get g of t is equal to t squared plus 3t plus 2. And so you just want to be careful that you don't forget to actually take the derivative of the function, because all we did is algebra, right? We didn't actually find the derivative. We just did some algebra manipulation to make it easier so that we can now actually use our derivative rules. And so the derivative of this would just be 2t plus 3. Okay. And so in part C, the idea with this one, and so we talked about this today in class, but the idea is that I'm using that a plus b over c is the same thing as a over c plus b over c. Okay, and you can kind of see that from the right, looking at the right-hand side, that since the denominators are both c, that you can just combine them by adding the tops together and keeping the same denominator. So we're kind of just working backwards here. So how I'm going to break up this fraction is this is going to be x cubed over x plus 4 over x, right? And if I simplify this, I get that this is x squared plus, now how I can rewrite this is I can rewrite this as 4, so I can rewrite this as 4x to the negative 1. So I need to rewrite that 4 times 1 over x, right, is 4x to the negative 1. Just so you can kind of actually see how I'm doing that, is it's like 4 times 1 over x, that's equivalent. But 1 over x is the same thing as x to the negative 1, because there's really like a 1 as the exponent in the denominator, right? It's just invisible here. And so I get g of x is just equal to x squared plus 4x to the negative 1. And now when I take the derivative, I get that this is 2x and then plus 4 times negative 1x to the negative 2. So this is equal to 2x minus 4x to the negative 2. Or you could also say, if you want to bring the x to the negative 2 and rewrite that, you could say it's 2x minus 4 over x squared. Okay. but both would be fine with me. All right, and then last but not least, we're talking about situations now where you need to use exponent rules to rewrite the expression before you actually find the derivative. So in this case, I need to rewrite the roots and, the division and stuff using exponent rules so I can actually use power rule. So see how this doesn't have a root? If it doesn't have a root number physically, like the square root, you need to put in the little 2 in the corner just so you can use these exponent rules. Okay, the little m here goes here, and then the n goes in the bottom, right? So this is going to be, so the root number is always the denominator. That's how I remember it. So this is going to be x to the 3 halves. And then this is going to be minus 5x to the negative 2. Oh. Okay, and so if I need to find the derivative of this now, I'm going to bring down the power, copy the x, and then it's to the power minus 1, minus, copy the 5, times negative 2x to negative 2 minus 1. So I'm getting that this is 3 halves x to the 1 half plus 10x to the negative 3. Or, again, we can rewrite these as our final answers here as 3 halves square root of x plus 10 over x cubed. Okay, so both of these would be acceptable. The reason why I'm simplifying them further is because, like, on multiple choice, it most likely would be given as the bottom one, the more simplified one. But if this was a free response question, as you know, there's no need to simplify unless for some reason you, need to have it simplified. Okay. So, yeah, so you do want to get practice with understanding and familiarizing yourself with both. Yeah.